F, which is everything together, but then you had the individual significances for each of your independent variables. And remember, if I ask you for the confidence interval for a coefficient, one of your V1s or V2s, don't overthink it. Excel gives it to you in the regression analysis. Right? The only confidence and prediction intervals for regressions that you have to calculate is chapter 14 for y hat.
Real quick on the bins, because I know you, like you said, a lot of us missed that. So as long as you do the equal countif right, and then everything else should flow pretty simple.
For qualitative data, that is correct. But when you have to create your own bins in terms of, even if it's quantitative, you have to do the 2K to the n to determine the number of bins. You have to take the min, the max, what is the range, and then you have to divide the range by how many bins you have. Then you have to round up to see how big your bin should be. If I have 5 bins, each bin should be 15 wide, so 1 to 15, 16 to 30, 31 to 45, right? And then once you have that, you put all your data into the bins, and once you have that, then you're good.
And then one more time, Professor, you said that when we did the OneTail test, you know, it's 1645 for one, and it's 1.96 for the other. And you said
only if it's Z, only Z, and if it is alpha 0.05, right? If it is Z and alpha 0.05, if it is two-tail, it's plus or minus 1.96. If it is a Z one-tail, it's either positive 1.645 or negative 6.6.5. So it's either for two-tail, or this is Z only. For T, you have to do the T.inv and the T.dist in Excel, right? Because it requires degrees of freedom, n-1 for chapter 9, or n-2 for chapter 10 with 2 populations. Right? There are sheets of tables, but I have to give you so many different sheets of paper because there's so many degrees of freedom and everything else. But for Z only, if it is two-tail, and it's Z only alpha 0.05, 1.96, negative 1.96, this is for a two-tail, because you have 0.025 here and 0.025 here in your rejection zones, right? For one tail, it is, if it's positive, it's ugly, but if it's positive, it's 1.645 here. If it's negative, it is negative 1.645. For Z only, alpha 0.05 only, one tail, and then there's 2 separate one tails, on the positive or the negative side, and then the two tails.
And for the other one, we have to go in there and do the norm.dist.
No. Norm.dist is giving you the p-value for Z, zebra. Norm.dist is Z. For T, you have to do T.dist to get the p-value. T.inv gives you the critical values for T. So flashcards are a great way to do it. So if you have, all right, so Z, all right. So what is my Z critical? This is those numbers. And how do I get my p-value for Z? P-value equals norm.s.dist. Second flashcard, when there's T, to get the T critical value, you do T.inv or T.inv.2t. To get the p-value for T, p-value T.dist or T.dist.2t. When do you use a Z? When we know the population standard deviation. When do we use a T? When we do not know the population standard deviation, when we're relying on our sample standard deviation. Right. Chapter 11 is our ANOVA. There's ANOVA single factor, or if we have a blocking factor, remember the blocking factor always has to be in the first column. Use ANOVA without replication, and then analyze it. The first results are for the blocking factor. If the blocking factor is significant, go to the next line and answer the question. If the blocking factor is not significant, delete, and do it again as a single factor ANOVA without the blocking factor.
Is the test going to look pretty similar question-wise to the questions that are on this?
Yes.
Okay.
Yep. That's one of the reasons why I gave you that.
And they'll be 50, approximately 50?
15.
15 multiple choice and about 5 short answer.
Oh, okay, so the same.
About the same, yep. But I'll give you the whole class period. All right? Have a good night. See you Tuesday. Good luck. Thank you. Did you give me your exam back?
Greg.
I know.
Oh, you didn't take it? Okay.
I give you my card, and you send me an email.
Do you have
No, I don't have
30 minutes on Sunday, Greg?
Huh? No, I'm gonna be wherever you tell me to be. I gotta get this.
Yeah, for real.
So whatever you tell me to do, I'll be there.
How about the early morning crack in the library?
Okay.
I don't. Whatever you say, man, I'm there. You don't have to ask me. Professor, could you kind of hit up for me and her what you told me in the office about that? Me and Ryan was talking about that, but you say it's pretty simple, Greg. All you do is go right here, and it was right there in the thing. Remember? You
Yeah, it's the coefficients. He was asking me what is the regression equation,
Yeah.
and it is data analysis regression, and it is the intercept and just the coefficients.
Right.
It's B0, B1, B2.
All right.
Got it, got it.
All right, do you guys have exams?
Yeah, I got my exam right here.
Very good.
Let me. Can I go? So I can go over there with him. Can I record it?
What?
Can I? So I can go over it with him? Yeah.
The Excel though, we're going to work on that.
I'll probably, maybe I'll get there a little early.
I'm up with that.
Check out the.
There's a lot of like conversions flying around.
Can you,
Yeah, thank you, Larry.
we need to get like
Check out those graphs I just added to what we had on the board before. I think it helps a lot.
Did you just send those out?
Yeah, during.
Then I'll see.
Yeah, well then I'll wait and draft it. I'll wait. I don't want to draft. I don't want to finalize it. Yeah, I'll go ahead and draft it.
Have all the data, it just doesn't look free. That's the problem.
Okay.
So, like, no numbers are gonna change or anything.
Okay.
We're just gonna stick them all in there.
Okay. Alright,
You
cool.
can just something like, I have to make deadlines.
Are you gonna? Here you are, Professor.
Thank
Are you gonna come and study with us?